Welcome to the Q&A session 14 from the playlist of JEE Advanced Physics Part 2. The topic is the electric flux through a spherical surface, and the question for this session was asked in the JEE Advanced examination in the year 2020. So the question here is, a circular disk of radius capital R carries a surface charge density given by this formula, that is sigma naught in bracket 1 minus small r divided by capital R, where r is the radius of the circular disk and small r is the distance of a point from the center of the disk, and this sigma naught is the constant. Now the electric flux through a large spherical surface that encloses the charged disk is phi naught. So this black circle is the spherical disk which I have made here, and these dotted lines depict the spherical surface which is enclosing this disk, and the flux which is passing through this spherical surface is equal to phi naught. The electric flux through another spherical surface of radius r by 4 and concentric with the disk is phi. So the ratio of phi naught upon phi is, this is what we have to find here. So phi naught here is the total flux which is passing through this spherical disk as depicted by this these dotted lines, and this spherical surface has completely enclosed the charged disk of radius capital R. So this will be equal to the total charge enclosed by this spherical surface divided by epsilon naught. Now so here we have to find the total charge which is enclosed by the spherical surface. So for that purpose, what I have done is I have considered one elemental ring here which is situated at a distance of small r from the center of the disk, having a thickness of dr. So the charge on this elemental ring can be taken as dq, which is equal to will be equal to the surface charge density, which is in this case is depicted by sigma r, into the area of cross section, so which will be equal to 2 pi r, which is the circumference of this ring multiplied by the thickness of it. So the total flux which is passing through this spherical surface will be equal to the integration within the limits of 0 to r, where r is the radius of this disk, of sigma r into 2 pi r dr. Now sigma r value is already given to us, so this is equal to 1 sigma naught 1 in bracket 1 minus small r divided by capital R into 2 pi r dr. So and this will be equal to this divided by this will be equal to divided by phi naught. So this will be equal to sigma naught 1 minus r by r 2 pi r into dr divided by epsilon naught. So on solving this, you can get this 2 pi and sigma naught can be taken outside, and I will be getting this equation as 1 minus r upon r dr divided by epsilon naught. So this is the value of the flux which is passing through this spherical surface which has completely enclosed the charged disk. This is the value. So we can say that this is the equation number 1. Similarly, we can also find the flux through another spherical surface of radius r by 4. So that is equal to phi. So this will be equal to 2 pi. Everything will remain the same except the limits of integration. 0 to r by 4 because the radius of this spherical disk is r by 4, and this will be equal to 1 minus r by r rdr divided by epsilon naught. So this is another equation which we have got. So if I divide both these two equations, that is phi naught upon phi. So what I will be getting is these terms, that is epsilon naught and 2 pi sigma naught, they will get cancelled out, and finally I will be getting the value as integration within limits of 0 to r 1 minus r by r rdr divided by integration within the limits of 0 and r by 4 minus in bracket 1 minus r small r divided by capital R into rdr. So this is the equation which I have finally got. Now we have to simply solve this equation in order to find the value of phi naught upon phi. Now this can be written as integration of rdr, and this can be written as integration of r square upon r dr from 0 to r divided by integration of rdr within the limits of 0 and r divided by 4 minus r square by r integration of r square by r within the limits of 0 and r by 4 dr. So the value of this integration will be equal to r square by, this will be equal to r square by 2, and here this r is a constant, so it can be taken out. So this will be the integration of this means that is r square by r dr. The value of this will be equal to that will be equal to r cube by 3, and by putting the within the limits of 0 and r, I will be getting the value as r square by 3. I will be getting r cube by 3, but here I am also getting 1 by r, so that will be equal to r square by 3. So similarly here I will be getting the value as r square divided by 16 into 2, 32, minus here I will be getting again r square divided by, this will be cube, so 16 into 4, 64, 64 into 3, so this will be equal to 623, that is equal to 192. So from here r square will get cancelled out, and I will be getting in the numerator as 1 by 6, and in the denominator I will be getting this 192 can be taken as LCM. So 192, the 32 into 6 is equal to 192, so this will be equal to 6 minus 1, 5 by 192. So this will be equal to 1 by 6 into 192 by 5, and finally this will be equal to 32 by 5. So the value of phi naught upon phi is equal to 32 by 5. So thank you very much for joining this session. In the next session I will be coming up with another topic from the chapter of electric charges and field. So till then, have a nice day. Bye.